Hello, September 24th. All right, let's do it. What do we have today? Triangle. Triangle array. Return the minimum path sum from top to bottom. This one is... I think I did this in Project Euler. It may move to an adjacent number of the row below. We'll formulate I plus 1 on the next row. Yeah, what was the solution on this one? I think it's the like dp-ish thing. It is not picking the smaller every single time. I think it is dp. Is it dp? I don't remember. I think it is to find the minimum that we can reach the bottom, and then we will yeah, I think it's the minimum. Hold on. If I remember right, we'll find the minimum that can reach here. Then we will find the minimum that reach here, minimum that reach here, right? So to find the minimum that reach here, so the minimum reach here is 4. So to find the minimum reach here, so I go up, right? So the minimum reach here will be from this. This is the minimum that will reach here. So from here we go to here, and the minimum that can reach here. So like this is the path. So for here, minimum reach here is the minimum of 6 and 5. Right, 6 and 5. So I need to find minimum 6 and 5 first. Okay, so I think it's a top down. So 2. So minimum to reach, minimum to go 3. This is 5. Minimum to 4. This is 6. Right. So minimum to reach here is 11. Minimum to reach here. So the smaller of the two, which is 11, 5. So it'll be 10. Minimum to get here is 13. Minimum for here is going to be 14. Minimum here is going to be 11. Minimum here is going to be 18. And minimum here is going to be 16. So the answer is 11. How would you code it? So I think I will just... it's like a queue, right? So each row, I'll look to the previous row, right? The previous row, and we'll just, yeah. I think that makes sense. Oh yeah, this is old question, very old problem. Is Project Euler still there? Yes, it's still there. Holy crap. I used to do this. I remember. I have to sign in. I don't know, do I still have my sign in? No, I forgot my sign in. Oh wow. Wow. How did they make money then? I don't remember, honestly. Yeah, and this is more mathematics centered. Yeah, but I haven't done this for a very long time. Yeah. Integer triangle, is this the one? No, I remember there's a path. And I remember it was quite tough when I was solving it back then. They are fountain equations. Is this path sum? Nope. Yeah, maybe I cannot find it, but I remember. It took me a long time to solve back then, but it was interesting. I think initially I had both, right? I solved one per day on this and on LeetCode on this, but eventually I think I just pivoted back to LeetCode because I feel LeetCode is more programming oriented. The other one is not. Anyway, this is 120. We'll DP it by finding the minimum, the min total ending at each value on each row. Okay, so what we need to do is, are you going to create new ones every single time? I think I am. So we'll have to do, so that's a pre, triangle 0, right? And then we're gonna say for I equal to 1. Yes, we have to go I equal to 1. Triangle dot size I plus plus, right? And then we'll do a new one, current, doesn't matter. And then, well, honestly, I think it'll be faster if we specify it's gonna be triangle I dot size. And then what we're gonna do is for int j equal to 0, j smaller than triangle I dot size, j plus plus, right? So for each one, I'm trying to find what is the smallest. So what do I do? What we do is j minus 1 and j, so we say int minimum pre-minimum, right? Pre-minimum shall equal to minimum pre-I, right? Pre-I is this, and then pre-I minus 1, right? So basically, if you're here, 0, 1, 0, 1, right? So it's this one, yeah. So it's gonna be pre-I. Pre-I, I think, always exists. Actually, no, that's not true. Ugh. So we have to do, oh my god. So it's gonna be I equal to 0. Oh, I don't like it. So pre-left. Okay, pre-L is going to be I equal to 0. If I equal to 0, then we want to find as a minimum, so I have to set it to maximum, so int max. Otherwise will be pre-I minus 1. This is the left, and pre-right is going to be I equal to triangle I dot size minus 1, right? So it's like the last one. If it's the last one, then it's going to be int max. Otherwise, it's going to be pre-I. And then I'll find out. Actually, I think I can directly say current j shall equal to triangle ij plus the minimum of pre-left and pre-right. Right? So we're done, move on. And then once we're done with everything, we'll reset pre-equal to current. That requires a copy. So maybe we can do move. We move it. So I don't have to copy. All right, so we'll blah, blah, blah. We keep doing this until at the end, we'll say res equal to int max. And, there is a way to get a, so C++, find max of a vector. I remember there is a faster way. Not faster, max element. Max element. So max element, blah, 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 and do this. Okay, so I think I can just do return std max element, yes. So at the end we pre-dot max element. Why max element? It should be main element. Pre-dot begin and pre-dot end. All right, let's give this a shot. That does not look right. I am surprised. 14. How is that 14? Oh, that is not I, my bad. That is J. That is very interesting. How do you figure? Oh, this is I. I and J. My goodness. There we go. I think this is right. That's kind of slow. Yeah, not sure why. Well, I think you know why. You want to be fast? Yeah. We can be fast. You want to be fast? Dude, we can be fast. Let's make it fast by modifying the values in place. So we don't need to do this. We don't need to do this. So this is no pre. This is a triangle I minus 1. And this is triangle I. This is fine. This is triangle I minus 1. And this is going to be triangle ij plus equal to. This is not necessary. This is going to be triangle the last. There's no last? Holy crap. I thought we had last. Ugh. And back. My bad. It's not last, it's back. Back. Alright, this is going to be fast, but yeah. I am just not happy that it take that long. See? That was the reason. 2021. It's actually not that long time ago. I'm surprised. I had multiple solutions in 2021. LIO cache. And 2022, did it again. Yeah, I think this one I was doing top down. No, bottom up. All right, that's it. I have no intention to do these. Let's go to contest. Let's go to this contest. Luck plus 10. It just gave me 10 points? What the hell? I'm not complaining. Alright, let's see what this one is. Maximum total subarray value. You are given an integer in nums of length n and an integer k. I might as well just turn these off because I don't think I'll ever do this. Oh, old problem. I don't even remember. Yeah, I think I never solved this one, actually. Yeah, I never solved this one. Nums of length n and integer k. You need to choose exactly k non-empty subarrays. Subarrays may overlap. Ooh, may overlap. And the exact same subarray can be chosen more than once. Exactly the same can be chosen more than once. The value of a subarray is defined as the max minus the min. The total value is the sum of the value of all chosen subarrays. Return the maximum possible total value you can achieve. So we'll choose k subarrays, right? Non-empty subarrays. And the exact same subarray can be chosen more than once. the value of a subarray is defined as max minus min, then why don't I just always choose the max minus the min? I don't know. Right? Why don't I just choose always the max and the min that contain the max? So you just find the max, find the min, and then find the difference and then multiply by k. That's kind of stupid, but yeah, sometimes you do need stupid questions, right? You need stupid questions to boost your confidence. Otherwise, you're gonna have to deal with all those difficult ones, which it's gonna just make you more depressed. It takes a lot of time, take a lot of mental energy to of nums, get their difference, and then multiply it by k. Yeah, it's just, I mean, from time to time, I know I should try some tough questions, but right now, no idea, no intention. I think it's max element, nums dot begin, nums dot end, and this will be minimum element, nums dot begin, nums dot end. Not sure. It could be right, could be wrong. But I think the test we can definitely pass. But I don't see how this could be wrong. That is how it can be wrong. Jesus. This is actually a good test, because if I do, all right, let's do static cast here. I wonder if it's I wonder if I only do the second one, does it work? That's always been my question. Right? It's always been my question. Does C++, when they do this, does it go with the first or does it go with the second? I think as long as you have one of them, I guess it's... Yeah, I mean, I don't know. I think we can make it faster by we're doing one pass and then we can find both, right? Yeah, let's say max nums 0. Maybe this one faster. Min is nums 0, right? For int I, y smaller than nums dot size, I plus plus, and we just do max nums I. Let's not do this way. Now return max minus min times static cast long k. This probably is faster, which I don't think so, but we can try. Yeah, it is faster. Okay, here's a question. If two values of different type are added or subtracted, multiplied, divided, what is the type of the result? For example, if int multiply long, what will be the result? What if it is long plus int? I think let's put these in backtick. Let's see, what does the AI say? Process known as usual arithmetic conversion to determine the type of the result. This process involves promoting the smaller type to the larger type before performing it. So as long as one of them is a larger type. Long double, float, unsigned long, unsigned long, unsigned int, unsigned short, char, boo. Ooh. So as long as one of them is long, then you're good. Good. It's good to know. It is good to know.